the distance between x, so x is just some number, and 0 on a number line. So we know that that's written as x with the 2 bars, and we have our example. 0 is here. We have 5, -5. Both of them are 5 units from 0. Okay, so it doesn't matter if it's positive or negative, the distance is the same. I guess people are getting kicked out. So remember how I'm pretty sure I told you guys, I think I told all the periods that the absolute value is really 2 graphs that meet at one point. Okay, so I don't know where I should write this. Maybe I should write it. We'll continue with this absolute value section. Like people keep getting kicked out of coming back in, so I have to keep stopping. So the absolute value is what's called a piecewise function. Does anyone remember what a piecewise function is? No? So a piecewise function is basically a function, but it has specific rules depending on what your x value is. Okay, so for example, if x is positive, your x is going to be greater than or equal to 0. If your x is negative, you'll have x is less than 0. Okay, so because they meet on that 0 point, that's why you get that V shape. Because although this one right here should give me an empty circle, the other one is a filled in circle. So it kind of covers both ends. Okay, so they kind of counter each other and just look like one graph.
So the negative one is always an empty circle?
Yeah, the negative one would be an empty circle, except that there's conveniently another graph that lands right on top of the 0 that's a filled circle. So they kind of cancel each other out there, and it just stays filled in, right? In all the piecewise functions we saw, we didn't see any that had a hole in it. That's because you have that second graph that covers it. So then when you would have, for example, we have our x, and we have our f of x. So we're not actually looking for y here. What we're just going to do is, in this case, go through. So using this piecewise, which equation does -8 use?
The negative x?
Yeah, so it would be the x is less than 0. And then -4?
Negative x?
Yeah, so again, the same. Now 0 would get which one?
X? No, equal.
Well, the one that matches the x. So it would be, it meets this requirement that x is greater than or less or equal to 0. So it would be x's. And then the rest are going to be the same one, right? So you'd see when you do the graph, what you're looking at is those types of equations. So the negative ones would match with this negative inequality, and the positive ones match with the positive one, and 0 as well. Okay. Now, when it comes to graphing, so there's a general transformation I don't know how I want to call this, formula or equation. We'll say equation. So the general equation is g of x equals a absolute value of 1 over b x minus h plus k. Okay, so now that I'm going to rewrite down here. And what we're going to do is I'm going to go ahead and switch colors. So A is going to be a compression or stretch. This is also compression or stretch. This is moving right or left, and K is moving up or down. So this general equation basically is just to help you figure out what is happening to your graph, okay? All those letters would be replaced by a number, which, we've seen before. You have x plus 5. My plus 5 means I move up 5. Or x plus 5 here, that means I move to the left 5, right? So this equation is simple because you can kind of look at it and see, based on your original parent function and your transformation, you can pick out, okay, here's a stretch or compression. Here's a change in the right or the left. Here's up and down. It kind of gives you a guideline for what you're looking for in your transformation. So if you were like trying to figure out, like we saw it on a couple of them in that study guide that said to graph the function, but they didn't give us any points. They didn't really give us anything. They gave us just kind of like this. And I showed you guys, okay, this is the transformation here and this transformation here. This is the equation that you'd want to look at to kind of figure that out, okay? So we'll do practice, don't worry. So now,
Ms. Perdomo, are we still
yes.
taking a quiz this week? Because it was supposed to be this week, right?
Yes. Oh, you guys are supposed to take it today. No, I canceled the test.
Okay, because also, oh, whatever. Wait, so we're going to do the test when you come in person?
No.
Oh,
okay.
Okay.
It's not fair to you guys that you have to wait 2 weeks before taking a test.
Right.
And I can't do 2 weeks of review. That's wasting a lot of time. So you guys got a freebie, no test. And
can I talk to you after class though?
yes.
Like on the Zoom meeting? Okay, thank you.
Yes. Okay. So moving on. I have to redraw my lines.
Wait, can you go back for a second so I could take a picture? I didn't get to finish. Thank you.
Mm-hmm. Remember, this is all recorded, so it'll go up on YouTube and I'll send you the link after.
Okay, I'm good. Thank you.
Okay. Oh no, I messed up. So now we are writing absolute values from a graph. Okay, so writing functions. I'm just going to call them functions. We're only working with absolute value in this chapter. So if I have to write absolute value every time, it's going to waste a lot of time. Writing functions from a graph. So we kind of already, I'm starting to think that that study guide covered both tests, so chapter 1 and 2, because we did this as well in the study guide, right? So you had, but now we have that given formula. I'm going to rewrite it. G of x equals a half of 1 over b x minus h plus k. So now we have this convenient equation. And what we can do is if they give us a graph, right? And let's say I'm now at, this is 1, 2, 3, 4, 5, 2, 3, 4. Oh, I'm too short. One, 2, 3, 4, 5. All right. So now I have the points, let's say 2, 5, and 6, 6. Okay, can you guys give me one moment? I'll be right back. So I have here the graph. I'm given 2 points, okay? So now remember that my original graph is always at 0, 0, right? So there's my original absolute function. Now, what I need to do is basically fill in these letters using the graphs, okay? Using my parent function and my new one, okay? So the parent one is gonna have what? Clearly this bottom one, this 2, 5, is my new, it's kind of hard to see in my graph, but it's the new point on the absolute value. I should make it look a little bit more better. That's pretty bad. Yeah, somewhere like that. To give it more of the point. So from 0, 0 to 2, 5, where do I move? How do I move?
Up. 2 to the
Up
right.
how many?
And 2 to the right and 5 up.
2 to the right and 5 up. So that means my new one, g of x, is going to be equal to, now I don't know any of these, a, 1 over b. Now we can kind of tell because the graph is wider, right? It should look wider. Again, on my graph, it doesn't look the best, but it should be wider than the original parent function, okay? So we're gonna leave the a and the 1 over b for now and just replace x, what? X plus 2 or x minus 2?
Minus 2.
Minus 2. Remember when it's with the x, it's always the opposite. So if I'm moving over right or left, I'm going to do the opposite. If I want to move to the right, I'm going to subtract. If I want to move to the left, I'm going to add. And then what? Plus what number?
2. 5.
5.
Sorry,
So
I have a different.
we moved up 5. So plus 5 at the end, okay? Now we need to figure out how we get that squish, okay? So they give us an example And it says let A equal 1. So they kind of help us out there and they tell us A is equal to 1. I have 2 points, 2,5 and 6,6. So I can now replace that A with 1 or just not even write anything. Remember that if I write this or I don't write it, it's the same thing. There's usually always that 1 hanging around. So now this is what our equation looks like, okay? Where you can not include the 1. It's the same thing, okay? Now, I want to try and figure out this B. Because there's definitely some change to the shape and the size of the graph. So I need to go ahead and fix that. So I'm going to use the points 6, 6. I'm going to change colors as well. So I'm going to use 6, 6 to try and figure out what B is. So that means I'm going to replace, remember, I had my G of X equals. I'm going to replace the Y and the X with the points from 6, 6, which is kind of easy because it just means it's 6 equals absolute value 1 over B, 6 minus 2 plus 5. Okay, now I can go ahead and solve. The first thing I'm going to do is my parentheses. Remember, we have our PEMDAS. So our parentheses go first. So 6 minus 2. 4 plus 5. Now I'm going to go ahead and combine my 1 over B times 4 over 1 is just going to give me 4 over B plus 5. Okay. Now what do I want to do next?
Subtract the 5 from 6.
Yeah, so I'm going to subtract the 5. That gives me 6 minus 5 is just equal to 1. So now, remember, we have to do our 2 absolute value equations with this 4 over B. So my options are 1 is equal to positive 4 over B, and 1 is equal to negative 4 over B. Okay, now what do I do?
Divide both sides by 4.
Not divide both sides by 4.
Multiply
Multiply by
B. 4.
B. I want to get rid of the B. So I'm going to multiply both by B because they're both the same steps, right? What I do to one side, I do to the other. And this is convenient because since it's times 1, all it tells me is B is equal to 4, B is equal to negative 4. Okay. Questions on that?
Why didn't we multiply 4?
Because we just need to get rid of the denominator. Remember, when you have the fractions like that, your main goal is to get rid of the denominator and leave the numerator as is. You know, as possible that you can. Okay. Does that make sense?
Yeah.
Okay. So now, because of our whole absolute value is the distance from 0 and distance is never negative, the only number that we're going to really use is the positive B equals 4. Okay? We understand why. There's no negatives with absolute value. It's always distance. So it doesn't matter. We don't want that negative there. We're just going to look at that B equals 4. So my final equation is G of X is equal to absolute value of 1/4 x minus 2 plus 5. That's my final answer. Questions on how we got there? We don't have any questions.
Wait, didn't we find x already? Wasn't x 6, or was that just a random point?
No, so we used the point 6, 6 to find what b was. But we're looking this.
Okay.
What you're really looking for is the general equation that if you picked any point on that graph, you can find what the y value is. So we wanted the general one, but to find the general, you have to use a specific point. Yes? We're good? Can I move to the next page? Should I? I'll wait a second. We're good to move on. Yes, maybe. All right. So the last one to go through is modeling with absolute value functions. So I'm actually going to share the screen for the textbook so we can just go through it together so you can see it's the same steps that we just did. This whole section is just on having the graph and finding the general equation for when you're, what is the word I'm looking for? When you're trying to graph it yourself using different points. So I'm going to go ahead and stop my screen share. I'm going to switch over and share this screen. There we go. So this is from your textbook. I figured it's the better way to go through it. So we have here, it's a whole word problem. The Science Museum exhibit. A beam of light originates at a point 10 feet from the floor. So you can see there, 10 feet. It is reflected off a mirror on the floor that is 15 feet from the wall. And the light originates from how high off the floor on the opposite wall does the light hit if the other wall is 8.5 feet from the mirror? Okay, so all it's asking you for is, let me see if I can do this. It's asking you for, what is it, how high off the floor on the opposite wall. So basically it's asking you, what's this point? Which we can't know without the formula. So the model will be in the form, will be of the form right there. That's our whole thing we've just been talking about. The vertex, they tell me, this point right here is at 15, 0. Okay. Another point is 0, 10. Okay. We see why those points are the ones that they are, right? I can see this is where my 0 against a wall is at 0, 10 feet up, and then 15 feet on the floor is the other one, so that's why it's 15, 0. And this is the one that I'm looking for. Okay. The opposite wall is 2.3. Well, opposite wall is 23.5 feet from the first wall. So the distance from this one to this one is 23.5. Okay. It's a lot of different information, but it's okay. We can get through it. So let the base of the first wall be the origin. So this here is my origin, meaning this point here is 0, 0. Okay. I really hate that my annotations move and they don't stay on the graph. Okay, you want to find the value of g of x at x equals 23.5, which will give the height of the beam on the opposite wall. Okay, we kind of already know that. We're looking for the one over there. It's a bunch of other writing, don't really care about right now. Last thing is that it says evaluate g at 23.5. Yes, we need to find the original equation, that transformation one, and then plug in 23.5 for our x in order to find out what our y is. Okay, so that one's kind of obvious. This whole bit of information is kind of useless, except I would say the first sentence, and then maybe the second and the last one. Otherwise, I don't really care to read the whole thing, except they do say let b equal 1. So that one is helpful. So we already know, I'm going to write it on the side, b equals 1. Okay, so the vertex at g of x is at 15, 0. That's the point where the point of the absolute value is at 15, 0. Substitute giving g of x is we have a, can you guys see the a clearly? Is that okay? Do I need to rewrite it somewhere else? Okay. A, the absolute value, x. Remember that we had our original g of x equals a absolute value 1 over b, x minus h plus k. So they've already told me b equals 0 or b equals 1. And now my x minus 15, because I'm going to the right 15 points. Okay, and I can close it. There we go, that's better. Plus 0. So remember, my k doesn't go up or down, it stays on that 0 point. I only move left and right from my original 0, 0. So we can see here, I only moved over, I'm still at this 0x point. Okay, so I didn't go up or down. Questions on that one so far? Any questions so far? No? Okay. Now, the only letter I'm missing is A. So now I need to take, remember I had that point and they wrote it right here for me, 0, 10. Okay, so now I'm gonna take that 0, 10 and I'm gonna plug it in. So instead of g of x, it's going to be 10 equals a absolute value of x, which is actually just 0, 0 minus 15. And then I'm not going to write plus 0 because there's no point. There's nothing there at the end. So 0 minus 15 is going to be what? Negative 15, which now I can actually just take the absolute value of that, which is 15. So 10 is equal to 15 times A. What's my last step?
Divide by 15.
I'm going to divide by 15 to both sides. Now I'm running out of space over there, so I'm going to have to write up here. So that gives me 10 over 15 equals A. Can I simplify 10 over 15? By what?
Miss Perdomo,
Yes.
since it's in the absolute value things, wouldn't it turn to positive 15?
It is positive 15.
Oh, okay, because you didn't wait. Oh, okay, I see now. It's like
you're just short.
blurry. Okay.
From the, oh yeah.
Simplify to 2/3.
It would simplify to 2/3. Both of them have 5 in common. So you divide both by 5. And that would give me 2/3 equals A. Kind of all over the place here. But now my final equation is g of x equals 2/3 absolute value of x minus 15. Yes?
Yes.
But I'm not, I'm almost done, but I'm not done yet. My last step is to plug in that 23.5. Remember, my whole goal was to find out what that point is on the end. So now I just go ahead and replace x with 23.5 minus 15. So 23.5 minus 15, I'll just do it in the calculator.
Why are we doing this again? I don't understand.
What are, like, why am I plugging in 23.5?
Yeah.
Okay, I have to scroll up. I keep trying to scroll up on my iPad and it's here on the computer. So it said that from here, from this 10-foot wall, this is really my 0. From here over to here is 23.5 feet. And I'm looking for this point here on this wall.
And why would plugging it into the equation find that point?
Well, it's going to find my y, right? Because g of x is the same as saying y equals. So y is equal to this whole thing. Because this is on the 23.5 on my x, when I plug it into my equation, it's going to tell me what my y value is. So it's going to tell me how high up on the wall the point is.
Oh, okay, I see now.
It's just like the regular function, but first we had to fill in the spots
I
on the
forgot
actual.
why we were there. I just thought we were solving a question. I forgot we were finding that height thing.
We are solving the question, but we had to do, so it's basically the same thing that we had done before. It's like a chart, right? But instead of them giving me the function, I had to kind of do a little bit of work to figure it out. Okay, so that's kind of what ended up happening. I had to do the work to find the actual function so that I can now plug in my values. Okay, and then, okay, I forgot where it was. Okay, 23.5 minus 15 gives me 8.5. The absolute value of 8.5 is just 8.5. So I'm left with 2/3 times 8.5. Ugh, it's gonna be horrible. I'm just gonna use the calculator because I mean, we could just do it with 1, which would then be 8.5 times 2, which gives me 17. Oh my gosh, I'm running out of space. G of x is equal to 17 over 3. Can that be simplified?
I don't think so.
No, right? They don't have anything in common. So I would just have to put it as a decimal, right? If they give me decimals, I want to keep it as decimals, even if I have a fraction at the end. So 17 divided by 3 gives me about 5.67. It's really 5.6 repeating, but I'm not putting repeating. I'm just going to round up. So there's my answer. So all this work just to find that little number right there. But that's it. It's not so bad, it's just a tedious, I would say. It's more tedious than anything. Any questions on this? All right, you guys can pack up. We're just about done for the day.